Okay, so my dear students, after solving the questions of the proof in the essay, as in we have seen in the last exercise, we have done the questions regarding the proof where we are given something on the LHS side and we prove for the RHS side. Alright, so now we are going to see the application of determinant, which I have stated you in the introduction of the chapter that the determinants are basically used for solving the linear equations. Okay, so that is what we are going to do now. We are going to see certain methods which help us to solve the linear equation. In n variable also we can solve. Okay, so here in front of you we are given the solution of linear equation by determinant. So let us start here. I have considered the system of linear equation in three unknown. As you can see that the three linear equations are in front of you, that is a1x plus b1y plus c1z is equal to d1. That is the first equation. Okay, a2x plus b2y plus c2z is equal to d2. Second equation, a3x plus b3y plus c3z is equal to d3. That is the third equation. Okay, let us consider this type of equation. Now in this equation we have to study about two types of linear equation. As in, this is a new topic for you. We have to just see that how many types of linear equations are there. So types of linear equation, there are two types of linear equation. One is called the homogeneous linear equation and second is called the non-homogeneous linear equation. Now what is the difference between homogeneous and non-homogeneous? Homogeneous, by the name itself you can understand that there is some homogeneity. Homogeneity means some similar type, and non-homogeneous, that means there should be some unsimilar. Okay, so from here what do we mean? That if your d1 equal to d2 equal to d3 equal to 0, if your constant term is totally 0, then that particular equation is called the homogeneous. And if this is not, that means if d1 is not equal to d2, or we can say that d1 equal to d2 equal to d3 not equal to 0. We cannot write like this, that it means that this 3 should not be equal to 0, all should not be equal to 0. Okay, so this is only the basic difference between homogeneous and non-homogeneous, and we are going to solve both the cases. Now we need to understand certain things, that what are the consistency conditions and inconsistency conditions in the non-homogeneous and homogeneous. First of all, should know the meaning of consistency or consistent solution. So if a system of linear equation which has one or more solution, then that system is called the consistent, and otherwise it is called a inconsistent. Okay, that means if a system of solution, that means if, say for example, we are considering this and it has a one or more solution, then we can say it has a consistent solution, else it is inconsistent. Okay, so now let us see the condition of non-homogeneous linear equation. So we were seeing the condition. So first, for the non-homogeneous system of linear equation, there are basically three conditions which we have to see in the question. The first condition says that whenever you solve a non-homogeneous system of linear equation, you can get a unique solution. Unique solution means if you have a three variable linear equation, then that means all the x, y, z, you will get a unique solution. Second one, infinite number of solution. You know the meaning of infinite many solution. And no solution, that means you won't get the solution from this condition. Okay, now what is this consistent and inconsistent? As I have stated in the previous that if you have one or a more number of solution, then it is consistent. So we can see that these two are consistent, but this is inconsistent. Similarly, we can see for the non-homogeneous system of linear equation, you have two types of condition, a unique solution and the infinite number of solution. For the unique solution, you will get a trivial solution or consistent. Now what is the meaning of trivial solution? For the x, y, z, if you get x is equal to 0, y is equal to 0, z is equal to 0, then we say that it is a trivial solution. This is a trivial solution. Okay, then infinite number of solution, that is also consistent one. Condition of consistency for for the homogeneous system of linear equation. Now let us now, as in the starting, I have stated that what is homogeneous system of equation. If you have a1x plus b1y plus c1z equal to 0, and similarly both the equation equal to 0, that means in place of d1 d2 d3, your d1 d2 d3 they all are equal to 0, then that is called the homogeneous linear equation. Now for checking the consistency, what we have two kind of condition. That is, if your d is not equal to 0, then the system has trivial solution. Now this trivial solution, I have again explained you that this trivial solution means if your value of x, y, z, if they are 0, then it gives the trivial solution. Now from the Cramer rule, if you have this x is equal to d1 upon d, y is equal to d2 upon d, and z is equal to d3 upon 3, that means if d is not equal to 0, that means this is not equal to 0, then maybe d1 d2 d3, if they are equal to 0, then you will get a trivial solution. Because you see, from the equation you have a1x plus b1y plus c1z is equal to 0. To satisfy this equation, that means to get 0, what is the possible value here? If I put x equal to 0, y equal to 0, z is equal to 0, then only we'll get 0 equal to 0, then only the equation will be satisfied. Hence your d1 d2 d3, if they are equal to 0, and if d is not equal, then you have the trivial solution. Secondly, if d is equal to 0, that means if your denominator is 0, then we can understand that it has a infinite many solution. Now we are going to see the very important phase of this chapter, and this would be the last topic of this chapter. Okay, and we are going to see the solution of three linear equation, that is the non-homogeneous three linear equation we are going to solve, and that is also we are going to solve by the help of Cramer rule, and this rule is very important and you have to keep in mind. Alright, so we are taking the three linear equation as a1x plus b1y plus c1z is equal to d1, and so on, like these two. Okay, let us start. See, I'm considering, let d be the determinant of the coefficient of x, y, z. Okay, I'm considering one d. Okay, I have not written. D is what? a1, b1, c1, a2, b2, c2, a3, b3, c3. Okay, and d1, d2, d3 are the coefficients when replaced by the coefficients of x, y, z. As you can see that this d1 I have written this d1 on replacing this x coefficient by d1 d2 d3. See, in place of x coefficient I have written d1 d2 d3, b1 b2 b3, c1 c2 c3, they are same in their positions. Okay, then what? See, d2 I have written a1 a2 a3, then in place of the coefficient, this coefficient I have written d1 d2 d3. In this, okay, in this d3, the coefficient will be, in place of z coefficients I have written d1 d2 d3. Now what does the Cramer rule says that to find the value of x, you divide d1 by d, you will get the value of x. Divide the d2 by d, you will get the value of y, and similarly for getting z, divide d3 by d. This is the d determinant. You have to find the value of this determinant. Okay, okay, now what happens that while solving the system of homogeneous linear equation, we get certain conditions for the consistency. All right, so we need to see those things also, that if while solving, if there is any condition of unique solution, infinite solution, or no solution, then what should be the case. So it is very important to point out here that for non-homogeneous linear equation we have three conditions. That is for unique one, that is second one is the no solution one, and third one infinite many solutions. So what are the conditions? So in the Cramer rule we have seen x, the value of x is d1 upon d, y is equal to d2 upon d, and z is equal to d3 upon d. So what is the condition of consistency? That if d is equal to 0, we know what is d, right? D is the determinant of the coefficient of x, y, z. If d is not equal to 0, then the system has unique solution. Okay, while solving the value of d, the determinant of a1, b1, c1, a2, b2, c2, and a1, a2, a3, b1, b2, b3, and c1, c2, c3. If your determinant is not equal to 0, then it has a unique solution. That means this d should not be equal to 0. If this d is equal to 0, then that will be an infinite value. So this d should not be. Then second condition, if d is equal to 0, then, and if one of them, that means d1, d2, d3 is non-zero, then also the system is inconsistent and has no solution. Okay, when your condition will give you no solution, when your d is equal to 0 and one of them, d1, d2, d3 is a non-zero value, then it will give a no solution, then system will be inconsistent. If your d, d1, d2, d3 they all are equal to 0, then the system has infinite number of solution. Okay, and regarding the consistency, it may or may not be consistent. Time to take an example and understand the concept of this more precisely. So I have taken an example here. As you can see that x plus y plus z plus 1 equal to 0, x plus 2y plus 3z plus 4 equal to 0, and x plus 3y plus 4z plus 6 equal to 0. Okay, some of you may be thinking that it is a homogeneous condition, but no, this is not an homogeneous condition. Why? Because here we have the constant value with us. All right, so this is not a every equation which has equal to 0 or RHS equal to 0 is not a homogeneous. You have to see that whether any constant value is accompanied with the linear equation or not. Okay, here we have plus 1 plus 4 plus 6, so this is a non-homogeneous linear equation. Okay, see, from this example many of your fundas will be cleared regarding the concept. Okay, so this is a kind of example I have taken where the question is confusing the student that it is homogeneous or non-homogeneous. So this is a non-homogeneous. Take this plus 1 this side. So on taking this plus 1 this side, we get this is equal to minus 1. Take plus 4 this side, so this will be equal to minus 4, and plus 6 this side, so this will be equal to minus 6. Alright, now let us start the procedure of finding the values of x, y, z. See, we need the values of x, y, z, and we need to see the consistency of this linear equation also. So first of all, let us write the d determinant, that is 1 1 1 1 2 3 1 3 4, like this. Then the d1, I told you what is d1. D1 is that determinant on replacing the coefficient of x with the coefficient of this d. So here minus 1 minus 4 minus 6, 1 2 3 same, and 1 3 4 same. Again d2 is what? This 1 1 1, this will be same, but on place of the coefficient of this y, we will write minus 1 minus 4 minus 6, and similarly d3 will be on replacing the coefficient of z, minus 1 minus 4 minus 6. Then we find the value of d. What will be the value of d? By using the determinant method that we have discussed before. Okay, take any of the row or column, expand with respect to that, and get the values. So I have written here the values of value of d, d1, d2, d3. All the values I have found out. Then by the Cramer law, we know x, y, z is what? X is d1 upon d, y is d2 upon d, z is d3 upon 3, d3 upon d. we got the values of x, y, z. Now how to check whether you are correct? So put these values on your equation, and if you are getting LHS equal to RHS, then you are correct. From here, see what you have to write after finding the value of D, that since D is not equal to 0, hence system of linear equation has a unique solution and it is consistent. Okay, this you have to write at last. Other type of question we are going to see on the same, that is non-homogeneous linear equation, but the another condition. Okay, so here as you can see that the equation is written there. Okay, I've just written here D, that is the coefficient of x, y, z, and I have found out the value of D as this. On finding the determinant, I got the value as 0. Now see, if ever you get the value of D 0, that means if D is equal to 0 on the very starting, then you have the two things in your mind. Then you should have two things in your mind. That is, first is it may be have a no solution, or it may have infinite solution, because what does the condition says for the non-homogeneous? That condition for the consistency of non-homogeneous, that if D is equal to 0, then it can have two, that is no solution and infinite solution. Now to just clear this thing, what we have to do, let us find the value of D1, D2, D3. Now what does the no solution condition says? That if D1, D2, D3, any of them have a non-zero value, then it is a no solution case or inconsistent. And if your D1 equal to D2 equal to D3 equal to 0, then it will give you infinite solution. So I have found the value of D1 and it came -10. Okay, how I have found D1? D1 says that replace the coefficient of x with this one. I have written here same, the y and z coefficient will be same, and I found out the value with the help of determinant method. I got answer as -10. So from the very D1, it is concluded that D1 is not equal to 0. Stop there. Don't try to find D2, D3, because there is no use of them. Okay, on the very first you got D1 is not equal to 0, hence it is inconsistent and it has a no solution. That's it. Okay, now let us come to the type 3 example of non-homogeneous linear equation. Okay, as we have seen for the unique case, we have seen for the no solution case. Now let us see for the infinite many solution case. This is the question written in front of you. Okay, I have calculated the D again. I would like to say that D is the determinant which is found by the coefficient of x, y, z. So D, I have calculated with the help of determinant method, and I got D is equal to 0. Okay, now if D is equal to 0, then again I told you that we must have two type of cases: no solution and infinite. No solution, what does it says? That if D1, D2, D3, any of them is a non-zero value, that means 0 should not come, then it will give you a no solution case. And if your D1, D2, D3 is equal to 0, then it is a infinite. So as I have found the value of D1, D2, D3, D1 is D1 determinant is which I told you that in place of x coefficient we are writing 1, 4, 7. I've written here and calculated with the help of determinant. Pause the video, you can check all the calculations. Okay, you can understand also. Okay, this is equal to 0. Now again D2 comes, this is equal to 0, and D3 also equal to 0. Thus D is equal to D1 equal to D2 equal to D3 equal to 0. Hence it is consistent but has an infinite many solution. Now what happens in this question? You need to do that it is a consistent and we have to find the solution also. See whether it has infinite many solution, but it has some pattern. That means we can we get x, y, z in terms of like I'm taking one constant k minus 2, k plus 3 and k minus 4. we can get the answer in this form also, no, where k you can put anything, 1 2 3 4 5 6, any infinite, up to infinite we can go. So like that we need to find the value of xyz in some general, that means we are going to find the general solution of this. Okay, whether it has an infinite many solution, but it has some general answer also. Okay, xyz, so we are going to do that thing. Okay, as I told you that now we are going to further solve it, because this is a infinite many case condition, that means we need to find some general answer. Okay, so let us go ahead and do that. As d equal to d1 equal to d2 equal to d3 equal to 0, it is consistent and has infinite many solution. So what is the criteria? See, this is the very important phase of the question. What is the criteria of solving for that? Okay, so let us solve the two equation for x and y in terms of z. So this equation can be written as, that means we are going to take two equation, first two equations, okay, and we are going to write those two equations in terms of z. Okay, so what I have done, this x plus y and this z I have taken, so there, so 1 minus z, and x plus 2y, 3z will go that side, so 4 minus 3z. Now using the Cramer law in this equation, from this equation our d is what, 1 1 1 2 1 1 1 2, the value of d is equal to 1. d1 will be what, in place of x coefficient 1 minus z, 4 minus 3z, this one, and 1 2 1 2 here. On solving this determinant, I got the value z minus 2 as the answer. This 2 will be multiplied here, so 2 minus 2z minus 1 into 4 minus 3z, so z minus 2. Then here d2 is what, 1 1, d2 will be what, this 1 1, and in place of this y coefficient 1 minus z, 4 minus 3z, so this will be multiplied here, minus this into this, the final answer is 3 minus 2z. Now according to the Cramer rule, x is what, d1 upon d, so d1 upon d, z minus 2 upon 1 is z minus 2, y is equal to what, d2 upon d, that is 3 minus 2z upon 1, 3 minus 2z. Now let z be any k. We are considering the z be any arbitrary value. This arbitrary value means any value you can consider. Then in place of z, it is replaced by k, that means the value of x is equal to k minus 2, value of y is equal to 3 minus 2k, and z is equal to k, which we have considered. Now here you would have been confused at why we are taking this k and why we are writing like this. So as I told you, it has infinite many solution, it has not a unique solution, that means we have to write it in the general form. So this is the general answer of x, y, z. You consider k is equal to any value. Okay, let me consider, this is the cross check, we are checking, okay, that this answer is correct or not. Let k is equal to, say for example, 1. What will be x? X is minus 1, y will be what, 3 minus 2 1, and z is equal to what, k we have considered 1. Now you put all this value in your equation. So on putting the value in the equation, what we are getting, x plus y plus z is equal to 1. So minus 1 plus 1 plus 1 equal to 1. 1 to 1 cancel, 1 equal to 1. Yes, hence verified. So like that you have to understand. All right, now this is we are going to see the homogeneous linear equation examples, and in the homogeneous linear equation examples we have seen the two conditions for the consistency, one for the trivial solution and one for the non-trivial solution, that is for the infinite many solution. Now let us take I've taken two examples here, okay, and from the example I'm trying to make you understand that, see, this example is written here. D determinant will be all the coefficient of x, y, z. Now value of d, by the help of the method of determinant, I have found out the value of determinant d, that is minus 10. Now if d is not equal to 0, now remember the condition for the consistency in the homogeneous linear equation, that if d is not equal to 0. If you don't remember, then go back and just see the condition, because those conditions are very important, you have to keep in mind. All right, so if d is not equal to 0, thus it is having a trivial solution, and from here we can conclude that the value of x is equal to 0, y is equal to 0, and z is equal to 0. Now let us come to the next example. This is the example D. See, this is a non-homogeneous condition. Why? Because there is no constant value, hence, and also we can see there is equal to 0. So this is a homogeneous linear equation. From here I have calculated the value of D. Okay, D is coming 0. Now it is a non-trivial solution. This is the second condition. We have seen that if D is equal to 0, then it has an infinite many solution. Now in the previous video, in the non-homogeneous, I've explained you how to solve for the infinite many solution. We have to take two equations in terms of z, take this z this side, 2z this side, then solve with the help of Cramer law and get the equation in the general form that you know how to do for the infinite many solution. Okay, you have to do and show it to me. Okay.